Hi guys, our second part of force, something again very interesting. So now we are going to discuss about contact forces and non-contact forces. Contact forces and non-contact forces. First of all, what is contact forces? Contact forces are those forces, you can write it down. Contact forces are those forces which appear when two bodies are having physical contact. Okay? So these are basically those forces which are applied on bodies having physical contact, like this is contact force. Now if I take this one, okay, take this one and hit somebody, then this will be definitely a contact force, right? If I take this one and hit somebody, definitely a contact force. Now you can understand what is contact force. If you still don't understand what is contact force, there is a hand with you, you can give a tight slap on your face and you will understand what is contact force right away, and definitely if you give it really tight, then definitely you will not forget what is contact force. So in physics there are different kind of contact force that we are going to study right now. So first contact force that we are going to study is definitely frictional force. Okay, but what is non-contact force? ये तो भूल गया था. Non-contact force. Contact force तो कब होगा? Contact force will happen when the two bodies are making physical contact. But there are certain forces where bodies are not making contact, but still it is having some force. Like magnetic force, you know, two magnets will attract each other or repel each other, right? It can attract, it can repel, but two magnets are not having any contact. It's a non-contact force. I am standing over here and I jump. Why do I fall down? Due to gravitational force. When it occurred on my body, when I was not having any touch with this ground, so there was a separation between myself and the ground, but the ground was still attracting me due to which force? Gravitational force, non-contact force. Next, there is another force that is called electrostatic force. When two opposite charges plus and minus are kept at a distance of separation, they are going to get attracted. Two like charges means plus plus or negative negative, same kind of charges are placed like this, they are going to repel each other. They are having no contact between them, still they are going to repel each other. Why does this happen? We are going to study, but those are non-contact forces. But definitely contact forces will be studied first, and it is one of the most important forces are contact force, because in daily life more or less you see and perceive contact forces rather than non-contact forces. Okay, definitely you see gravitational forces also, but we tend to give our emphasis in life more on contact forces rather than non-contact forces. Okay, so first force is we are going to study right now is frictional force, which is a contact force. Frictional force. Frictional force. We will denote this by capital F. Okay? We will denote it like this. Okay? Capital F, small f. Okay? This will be our denotion. One by one we will finish out. We are not going to be in any hurry because we are going to study in detail. Suppose there is a table like this and you have put a body and you are pushing it like this. So there is a force acting on it which you are pushing. We are going to study about force also. We have already studied about force, I think, right? So force is basically a vector quantity, so it has to be denoted like this. Okay, vector quantities are denoted like this. So this force is acting on it. So whenever this force is pushing the body, body will move this side. So this force F that you can see, F will move the body towards right, or tend to move, मतलब either it will move it or it will try to move. ठीक है, all the time it may not be successful. ठीक है, So sometimes they may be successful, sometimes they may not be successful to push this body. So whenever you push this, there is another force resisting this push. There is another force which is resisting this push, and this force is called nothing but frictional force, which is resisting this push. This frictional force is always opposite direction, opposite matlab direction, opposite of मोशन और इंटेंडेड मोशन, क्योंकि मोशन हो सकता है नहीं भी हो सकता है. If the force that you are giving is more than the frictional force, there will be motion. है ना? If your force is more than the frictional force, there will be motion. But if your force is like, here is a table over here, I hope you can see this, I am not sure, but here is a table, okay. So I am pushing it right now, I am giving some force, actually I am not being able to move it, but if I increase my force, I am able to move it now, okay. So you can see my force has exceeded the frictional force between the table, the stools and the ground, right. So when it increases or it crosses the frictional force, then table will move. But if F is lesser than or equal to frictional force at the start, okay, at the start there will be no motion. At the start there will be no motion. But there are many important nuances to this, which I am going to discuss right now. So suppose force is more than frictional force, that means I can say force minus frictional force is more than 0. So there is some positive value, some net force that is occurring this side. If the force over here on the right side is F, and if the force on the left hand side is F, there must be some net force acting over here. So I can write this F minus FF is equal to some F net force which is there, which is not equal to 0. If it was equal to 0, it would not have come more than 0. Okay, some F net force is occurring. So this F net I can write as mass into acceleration, okay, acceleration. So definitely as this part is not is equal to 0 and more than 0 actually, so A must be more than 0. So this is accelerating, clear? Grabbing this part. So try to understand this by mathematics. Don't try to rote learn. Let me say you, if you try to rote learn, you will face lot of difficulties later on. Then don't come to me. Huh? This is what teachers say. Huh? You will face difficulties later on, then don't come to me. अरे ऐसा नहीं यार, difficulty होने से भी आ जाना. Our work is to solve your difficulties. ठीक है? Maybe 1000 times, it doesn't matter. Okay, accelerating. Next is, if this F is equal to frictional force, exactly equal to frictional force, that means I can say that F minus FF is equal to 0. ठीक है? So that means I can say this F net which I was talking about is equal to 0. That means I can say this MA which I was talking about is equal to 0. That means I can say that acceleration which I am talking about is equal to 0. What are the conditions that can have this? This can be possible if the body is, number one, body is still, that body is not moving at all, body is still, okay, or body has uniform velocity. These are the two conditions which needs to be fulfilled. Clear? Interesting है ना? बहुत interesting है. देखो आपको बुक में चले जाओ यार, कौन सा इसमें, you will see something written like this. Paragraphs are, who likes to read paragraphs here? Do some equations, mathematics करो, तब तो मजा आएगा. ठीक है? Okay. But see, what happens is, this force that we give F causes the motion. Friction always restricts the motion. Please write it down. Our force causes the motion. Friction will be restricting the motion. So they are always on the opposite direction. ठीक है? They are always on the opposite direction. Frictional force is on the opposite direction of the motion or intended motion. ठीक है? लिख लो यार. In normal physics that we are going to study in class 9th and 10th, we are going to consider this frictional force as negligible, that is 0. ठीक है? 0 पकड़ेंगे इसको, हम ज़्यादा स्टडी नहीं करते क्लास 11th 12th में, इसको ज़्यादा स्टडी करते. ठीक है? ओके. नेक्स्ट, इतना कुछ पढ़ लिया, सब कुछ जान लिया, फ्रिक्शन होता है, लेकिन did I ever say why does this friction happen? No, you should have asked this one. You should have asked me this question, why does this friction happen? See, if I take an enlarged view of the tabletop and the block that I have kept overhead, then it would be like this, because definitely no surface is perfectly smooth. So this is the enlarged view. So here you can see these things. Okay. So whatever you can see right here, right now, are basically, sorry guys, is it visible? Okay, thank you. Okay, are basically nothing but atom to atom contact, right? Due to this atom to atom contact, there is some force of attraction developed between this. Okay, and these things are basically called instant cold welds. Normally welding happens while it is hot, but these things are basically called instant cold welds. So there are certain attraction between two atoms like this, which causes the restriction to the motion. ठीक है? So this is the reason why frictional force exists. ठीक है? थोड़ा chemistry भी है, atom to atom contact, not only physics. Both subjects are actually same, they are not different. It is made different here. Okay? Both subjects are actually same. It is just made different. ठीक है? Clear हो गया? Frictional force, guys. So that is all about frictional force that you need to know at this moment of time. Definitely, while you study about frictional force in detail, there will be coefficient of friction, there will be sliding friction, rolling friction, static friction, which friction will be more, which friction will be less, which will be in the middle, and all those things will come up. But up till now, whatever you have studied is okay. Okay, so I hope you have understood friction mathematically rather than rote learning, and you will be able to do any kind of questions asked on it. Thank you guys. Coming up with further more interesting topic just after this. Hello guys. So another very important force that we are going to study over here, that also we see in our daily life, that is normal reaction force. So you need to understand that first before studying it. So suppose this is you. You can take me also, no issues. Okay, and you are standing on a sofa. you are standing on a sofa, right? Sofa, sponge, ठीक है ना, deform हो गया थोड़ा सा. So whenever you stand on a sofa, what happens? The sofa deforms. Sofa deforms. Why? Because there is a force that is called force of gravity which is acting downwards. So at this moment only force of gravity is acting downwards, you can see that. So this force of gravity, if this is the only force that is acting downwards, it should take you down, right? It should take you down. But do you fall? No, you don't fall. The sofa gets deformed and you still stand there, but you don't fall. So next fact is that you don't fall. So first thing is sofa deforms. Number 2 is Fg, if it is alone then it should take you down. But the third fact is also true, that you don't fall. Now these are the facts, and behind every fact there should be some reasons. So why you don't fall? Because as the sofa deforms, deformed sofa pushes with a force up on you. This is nothing but normal reaction force. This is nothing but normal reaction force. Clear? So if it was alone, then you should have gone down, down and down. Definitely this sofa is giving you some force which is making you stable. Okay. So at this moment you are like this, you are like a body on which here is a Fg acting and here is a Fn acting over here, and this both Fg and Fn are equal at some point, so that you are not moving either up or down, either down or up. Okay? So you are remaining stable. Why? Because these two forces are equal. These two forces are equal and opposite. That is why I have given this minus. Okay? Equal and opposite. Understood what is normal reaction force? These two forces are equal and opposite. The gravitational force is acting downwards. Normal reaction force is by the sofa towards you, which is acting upwards. Okay? So this is happening in case of sofa. But what happens when you are standing on the floor? The same thing is happening. So you may ask, sir, does the floor deforms? Yes, the floor also deforms. Now you will say, floor is rigid, sir. No, no body is perfectly rigid. I have already said this. So it will deform. Maybe very small, but it will still deform, because no body is perfectly rigid. Okay? So even the floor deforms. Clear? Now let us just change this whole topic into some mathematics again. So this is a tabletop on which a block is there like this. There is a gravitational force acting like this. There is a normal reaction force which is acting like this. Okay? So definitely there can be some, there is a possibility I am seeing. There may not be also. If it is steel, then nothing is happening. But suppose if due to some reason this is moving up. And why it is moving up? So there must be some net force which is acting over here. Net force upwards. When net force will be upward? When the net force will be upward? The net force will be upward if F net. What is F net? F net is nothing but normal reaction force minus Fg. This is F net, nothing else, right? Normal reaction force minus Fg. And when this body is going to go upwards, only if F net is more than 0, right? If F net is more than 0, this is going to go upwards. Now if I want to calculate, suppose I want to do it like this, I am just changing it, I will write it over here. Can I write it like this? Fn is equal to Fg plus F net. right? What is Fg? Fg is nothing but gravitational force. So there I can write mg plus this one I can write may, means acceleration on the y direction, because it is moving upwards, y direction, y axis. So here on you can, mg plus ay. Okay. Now suppose let's take, there is some acceleration, the body is moving up, there is some acceleration, what I want to say is there is some acceleration of this body upwards. So ay is more than 0. So if there is this is an accelerating body upwards, ay is more than 0, then fn, fn is equal to fg, which is mg, fg plus may. As this ay is more than 0, mass cannot be negative, right, my dear friends? So as this ay is more than 0, so definitely this total part is more than 0, right? So can you say that Fn is more than Fg? Yes, it is possible if the body is accelerating upwards. It is possible if the body is accelerating upwards. Okay? Remember this thing. Okay guys, clear? So this is if the body is accelerating upwards. Number 2, this is for ay more than 0. So this is number 1. If ay is equal to 0, that is there is no acceleration of the body upwards or downwards, then Fn is equal to Fg. Why? Because Fn is equal to Fg plus may, ay is 0, so this part is becoming 0, so Fn is equal to Fg, simple. So Fn becoming Fg. That is the case which we have done earlier when both the forces are equal. But this can happen in 2 conditions again. This can happen either if the body is still or no change in velocity. It may happen the body is moving upwards but with no acceleration, the velocity is same. Okay? In that case also this acceleration will be 0 and Fn will be equal to Fg. But if there is acceleration of the body upwards, Fn, the normal reaction force, will be more than Fg. Clear? Little bit higher concept. Try to understand it. I think we have explained it in a normal way, so you will be able to understand it. I am pretty sure about it. Okay? So if somebody asks you, where does this Fn acts? This Fn acts for this one by the tabletop on the body. And where does this Fg act? By the body on the tabletop. Simple. It is equal and opposite. Most of the cases, if the total frame is not accelerating upwards. So what happens if I put this total thing in an elevator, that is in a lift? आजकल तो सब फ्लैट में रहता है, सबके लिफ्ट है बड़ा बड़ा, ठीक है, बड़ा आदमी सब. तो in case you are traveling on a lift and you have this tabletop and the block and the lift is accelerating upwards. So in that case the normal reaction force acting like this is more than the gravitational force acting down. Here is the proof of it. You can check it whether it really happens or not. Okay. Now another question might be coming into your mind at this moment, should be in fact, that should be coming into your mind, that while I am in an elevator is accelerating upwards, what happens? What happens then? Elevator is accelerating upwards, what happens? Let's see this. It's a nice one. I'll cover this right now. Elevator and me. Please give the heading, elevator and me. Very nice one. Okay. So there are different cases over here. I will consider different cases. So first of all, let me consider the simple cases. The elevator is still. Okay, still, ekdam still elevator. So this is me or you, whatever you want to. Okay. Elevator is still at this moment. So if there is still, that means there is a force of elevator that is acting on it, which is basically nothing but the normal reaction force, and there is a force which is gravitational force which is Fg. But there is no net force on the elevator. That means what is there? There is no net force. What does this mean? No net force. No net force means acceleration basically. No net force means no acceleration. So this can happen in two cases. One is the lift is still, that is the elevator is still, or same velocity. It is going up or down with same velocity. So in this case there is no net force. Okay? So in this case what happens is F elevator is equal to Fg. F elevator is equal to Fg, nothing else. ठीक है, सिंपल बात है. ठीक है. Now what happens? I hope you have copied it, otherwise you can pause and copy it, no issue. Next is, suppose it is an accelerating lift. It's an accelerating lift. So that means there is some F net which is there. That means there is some F net which is there. ठीक है. Now what is this F net? It is net upward force. So definitely accelerating lift, accelerating upwards. So let's take this. So if this F net should be F elevator, the upward force, minus Fg, okay, this one. So if I want to calculate F elevator is equal to F net plus Fg. So if this F net is more than 0, which is in this case, so definitely we can say that F elevator is more than Fg. So at this moment you can see your normal gravitation force से आपका elevator का जो push है वो ज़्यादा है. When the lift is accelerating upwards, so it has become more at this moment. So what happens there right now? थोड़ा सोचो. अभी आपके माथे के ऊपर से एक स्प्रिंग बैलेंस लगा दिया, ठीक है, to measure your weight. What will happen? The net force that is acting on the spring balance like this, the support force is basically the elevator's support force, nothing else. Okay? And this support force is now more than your actual weight. Okay? So what you feel like this? Like suppose I am standing, you are accelerating up like this. So what I feel? Because this elevator is giving me much more force than my exact body weight. Now while I am standing like this, there is no acceleration. Whatever reaction force I get is equal to my weight. So I know what is my weight at this normal position. Now suddenly you started pushing me up like that. So I feel my weight has increased. Because elevator's support force is my apparent weight. This is nothing but apparent weight, which is more than mg. If the elevator is going up with an accelerating force, it just happens when your elevator starts from the ground floor. You please check it out. It will be a very interesting experiment. Please check it out. ठीक है? ये होता है या नहीं होता है? ठीक है? Now this is accelerating upwards. What happens if it accelerates downwards? What happens if it accelerates downwards? If it accelerates downwards, definitely this F net is equal to, I will take a same F elevator. So if it accelerates downwards, let me draw this picture. So this F net is coming down, nothing else. So if it is coming down, then definitely this Fg is more than F elevator, right? Fg is more than F elevator. So in this case you can see Fg is nothing but F elevator plus F net, and this F net is more than 0 because I have taken this as downward force. So definitely I can say over here Fg is less than F elevator, right? Fg, did I do some mistake? F elevator, yes, sorry, how can this happen? Very sorry. Fg is equal to F elevator plus F net. Okay. Okay. Now you can see now F elevator is getting added with F net. So I can write F elevator is equal to Fg minus F net. Okay. Mathematically, nothing else. So definitely now you can say that F elevator is less than Fg. So when it is accelerating downwards, you will feel your weight has reduced, and you must have experienced this in your complex. Anybody who lives in complex with a lift or somewhere you go like that. So, you can see at this moment, if it is accelerating downwards, then you feel your weight is reduced. But let us go for extreme level weight reduction. You want to reduce your weight. Now, people goes to gym to reduce their weight a lot. Let us see what physics says about it. This is the lift, and suppose if the cord breaks, what happens now? The cord has broken. Now, definitely if the cord has broken, there is Fg that is acting, and there is a F net which will carry it downwards. There is no support because the cord has broken, no reaction is coming. So, what happens right now? This Fg becomes equal to F net, and you can write down this F elevator is 0. So, नीचे से कुछ नहीं आ रहा है, हल्का सा हवा में हम गिर रहा है. Okay, this is a perfect condition of a free fall, and definitely the lift as it falls down is going to accelerate down, right, because the G is going to pull it, increase its velocity, and you will feel complete weightlessness, because this F elevator, this support force what I have said is apparent weight. This apparent weight is 0. This is the condition of weightlessness. This is the condition of weightlessness. There will be no weight at all. You will feel no weight of your body while you fall down like that. Your cord is broken. Okay. So, this gives a very nice experience. Sometimes some books call it exhilarating experience. If I am not wrong with my spelling, exhilarating experience. But until you hit the bottom. So, this bottom, when you hit the bottom, you will suddenly feel a reaction which is equal to the total force that has come down, and you will feel a real shock and most probably will die. Okay? So, that is it about normal reaction forces with a very important example of elevator. Please try this at home, at least class 9 student. Please try this at home so that you get a feel about this. Okay, this is required. Don't try this at home. Statutory warning, don't try this at home. But other than that, you can really try this at home, right? You can go on and down and up in your lift, in your complex. ठीक है, काका काकी थोड़ा चिल्लाएगा, इतना बार लिफ्ट में जा रहा है, लेकिन ठीक है यार, फिजिक्स के लिए जा रहा है, ऐसे नहीं जा रहा है, खेलने के लिए नहीं जा रहा है. So please do that so that you get through this concept very well understanding. That's what I want. After this, we are going to study another 2 important contact forces, 2 or 3, I think 3. Okay, tension force is there, collision force is there, and your restoring force is there, that is the spring force. All those things, those are small topics. These 2 I have covered in detail, but those are small topics. ज़्यादा time नहीं लगेगा. ठीक है? Thank you.